Hey everyone, today I'd like to share my project on the effect of homemade herbicide on Daphnia Magna. We got a lot to go through, so let's get into it. The first thing I'd like to do is provide some background information about my project. The majority of commercially used herbicides contain a chemical called glyphosate. An example of this type of herbicide would be Roundup or Rodeo, which you might be familiar with. While this chemical has been tested and is currently approved by the EPA, or Environmental Protection Agency, many claims have surfaced about the dangers of glyphosate. This chemical is not only dangerous for humans, but potentially other organisms as well. A safer alternative must be found that has little to no effect on the environment. Many people that want to take a safer route decide to make their own, and you can make your own with things you have around your house. The defining question of this project is whether or not a homemade herbicide will affect the heart rate of Daphnia magna. Daphnia was used as a model organism because it is a good indicator of how certain substances will affect other organisms in the environment. For example, testing a homemade herbicide on Daphnia will give us a prediction of how other organisms will respond to that same herbicide. The hypothesis is that as the concentration of herbicide increases, then the heart rate will also increase. So now I'd like to show you guys my procedure and how I went about conducting my experiment. So the first thing I did was actually make the homemade herbicide solution. I like to point out that there are a bunch of different options to choose from. I just chose one that contained water, dish soap, vinegar, and table salt. The data was collected by placing 10 Daphnia in 4 different concentrations of homemade herbicide. First, I placed 10 in the 0% group, which was also the control group. It had no herbicide in it. I placed 10 in the 1% group, 10 in the 3% group, and 10 Daphnia in the 5% group. After 5 minutes of being exposed to the solution, the Daphnia were placed under a microscope individually so that the heart rate could be recorded. The way that I did this was that I used my iPhone camera and I recorded a slow motion video of the Daphnia under the microscope. Each organism was recorded for 15 seconds. The number of beats that occurred within that 15 seconds was counted and multiplied by 4 in order to calculate the heart rate in beats per minute. And I did this because if any of you have ever tried to count the heart rate of Daphnia under a microscope, you know that they go very fast, and this was a good way to slow it down and be able to count the number of beats. So let's take a look at the data I collected and what that means. The organisms with the highest heart rate were the ones in the control group, with an average heart rate of 368 BPM. That's this blue column here. This average heart rate kept decreasing as our concentration increased. So if we take a look at our red bar here, that's our 1% group that had an average heart rate of 298 beats per minute. Our 3% group here had an average heart rate of 237 beats per minute. And our 5% group had the lowest average heart rate of 191 BPM. This data means that as the concentration of herbicide increased, the heart rate decreased. These results are statistically significant as the p-value for each experimental group was much lower than the 0.5 that we needed. So based on the data that was collected in this experiment, the original hypothesis was refuted. It should be noted, however, that the herbicide did still impact the heart rate of Daphnia magna, and therefore this particular homemade herbicide doesn't solve the problem. So now you're thinking, what's next? What would I do different if I were to do this again? So if I were to continue this project, there would be some changes I would make. I think a more effective way to determine which homemade herbicide is safest would be to administer different solutions to Daphnia while the concentration is controlled. The safest herbicide solution would be the one that has the Daphnia with the least change in heart rate between it and the control group. Ideally, there might be an herbicide solution out there where we detect no noticeable change. And in that case, that would solve our issue of finding an herbicide that has no negative impacts on the environment. So that's it for this project. I hope you guys enjoyed. Hope you learned something new. And have a great day, everyone.